Berlin, the morning of January 30th, 1943, 0900 hours. Hauptmann Klaus Fischer stood in the operations room of Jagdgeschwader Twenty-Six at Werneuchen airfield, watching his radar operators track what appeared to be 3 high-speed contacts approaching from the northwest at 400 miles per hour. Altitude 28,000 feet. Bearing direct for the Reich capital on the 10th anniversary of Adolf Hitler's assumption of power. The day Reichsmarshal Hermann Göring himself would address the nation by radio at precisely 1100 hours from the Air Ministry building in the heart of Berlin. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Fischer ordered immediate scramble of 6 Focke-Wulf One Ninety fighters, confident that German radar technology and his experienced pilots would intercept these intruders long before they reached the city, completely unaware that the aircraft racing toward him were constructed primarily of plywood and balsa wood, giving them a radar cross-section so small that his Freya radar operators were reporting contact strength barely half that of conventional metal bombers, making the de Havilland Mosquito not just the fastest bomber in the world at that moment, but inadvertently one of the first stealth aircraft in aviation history. The Luftwaffe had trained Fischer and every fighter controller in the Reich on a fundamental principle. Radar gave Germany absolute situational awareness over its airspace. The Freya early warning system, operating at 125 MHz with a wavelength of 2.4 meters, could detect bomber formations at ranges exceeding 120 kilometers, providing ample time to vector interceptors into position. The doctrine held that no enemy aircraft could approach German cities in daylight without the Luftwaffe knowing its exact position, altitude, and heading. This technological advantage, combined with experienced pilots flying the finest fighters in Europe, made daytime raids suicidal for the British. Yet this morning the radar returns Fischer watched seemed impossibly faint. The operators reporting signal strength that didn't match the calculated size of the formation, forcing repeated confirmation that the contacts were indeed hostile aircraft and not atmospheric anomalies or equipment malfunction. At precisely 10:57, the 3 contacts disappeared from radar screens entirely, diving toward Berlin at speeds exceeding 420 miles per hour, too fast for the Focke-Wulf fighters climbing desperately to intercept. These weren't the lumbering 4-engine Lancasters that German fighters had learned to destroy. These were de Havilland Mosquito Mark IV, bombers of Royal Air Force 105 Squadron, each carrying a single 4,000-pound high-capacity bomb, nicknamed the Cookie, racing toward the broadcasting center at Wilhelmstrasse at a velocity that made interception mathematically impossible for conventional German fighters starting from ground level. 23 minutes earlier, Squadron leader Robert Iredale had led his 3 Mosquitoes across the Dutch coast at wave-top height, climbing only when safely beyond the range of coastal radar stations, accelerating to maximum continuous power settings that pushed the twin Rolls-Royce Merlin 21 engines to their operational limits. Each engine generated 1,500 horsepower, driving 3-bladed de Havilland hydromatic propellers that pulled the wooden airframe through the sky, at speeds conventional wisdom said were impossible for a bomber. The Mosquito's empty weight of just under 14,000 pounds, combined with its streamlined design and wooden construction, created a power-to-weight ratio that outperformed every German fighter except experimental types not yet in operational service. The British had stumbled onto something the German engineering establishment refused to believe possible. That an aircraft constructed primarily of wood, a material the Luftwaffe considered primitive and obsolete, could achieve performance levels exceeding the finest metal aircraft in the world. Geoffrey de Havilland's controversial decision in 1938 to build his new bomber from wood rather than aluminum had been driven partly by material shortages, but primarily by his conviction that wooden construction, properly executed, could produce an airframe lighter and more aerodynamic than metal. The DH-88 Comet racing aircraft had proven this concept, but applying it to a combat aircraft represented a gamble that nearly killed the project multiple times. The Air Ministry had almost cancelled the Mosquito program entirely in 1940, viewing the concept of an unarmed wooden bomber as fantasy. Only the desperate need for aircraft following Dunkirk, combined with the realization that wooden construction would use a completely different industrial workforce than metal aircraft production, kept the project alive. Piano factories, furniture workshops, and boat builders across Britain could manufacture Mosquito components without impacting production of Spitfires and Hurricanes, creating parallel production capability from resources otherwise unavailable for aircraft construction. The wood itself represented advanced composite engineering that German intelligence consistently underestimated. 3 layers bonded together. Ecuadorian balsa wood sandwiched between 2 layers of 3-ply birch harvested from Britain, the United States, and Canada. The balsa provided structural rigidity while minimizing weight. The birch plies added strength and stiffness. The entire assembly bonded with high-performance casein glue developed specifically for the Mosquito, creating a monocoque structure that could absorb battle damage that would tear apart aluminum. Airframes. Conventional wisdom held that wood would splinter catastrophically under stress. Instead, Mosquito airframes flexed and absorbed impacts, with bullet holes that would expand and propagate in metal, simply creating small punctures in wood that rarely affected structural integrity. As Iredale's formation crossed into German airspace, they flew past radar stations that detected them, but couldn't properly identify them. The Freya radar system required metallic objects displaying length normal to the radar beam of more than 1.2 meters to generate strong returns. The Mosquito's largest metal components were the Merlin engines at 2.9 meters long and the propeller hubs, but their angle to the radar beam and the surrounding wooden airframe scattered and absorbed enough radio frequency energy that radar operators reported contact strength inconsistent with bomber-sized aircraft. Some operators initially classified the contacts as fighters, delaying proper threat assessment until the Mosquitoes were already deep into German airspace. This reduced radar signature wasn't intentional design but fortunate accident. De Havilland engineers had focused entirely on speed and payload, never considering radar detection because operational radar barely existed when they began designing the DH-98 in 1938. Yet the combination of wooden construction, hidden radiators within the wings, and minimal external protrusions created an aircraft that German radar struggled to track effectively. This accidental stealth characteristic, combined with extreme speed, made the Mosquito nearly impossible to intercept once detected. At 1100 hours exactly, as Goering began speaking into the radio microphone at the Air Ministry, Iredale's Mosquito screamed over central Berlin at 400 miles per hour, releasing its 4,000-pound cookie from 23,000 feet. The massive high-capacity bomb, shaped like a metal cylinder rather than a conventional bomb, contained amatol, high explosive, designed to create maximum blast effect against urban structures. The explosion detonated 2 blocks from the broadcasting center, the shockwave powerful enough to shake the building and disrupt Goering's speech mid-sentence, forcing engineers to cut the transmission while the Reichsmarschall recovered his composure. The psychological impact far exceeded the physical damage. The fact that British bombers had reached Berlin in broad daylight, on this specific date at this precise moment, during the most important propaganda broadcast of the year, represented a humiliation the Nazi leadership couldn't explain. German citizens listening to the radio heard their Air Force chief's speech interrupted by explosions, then resumed with audible strain in his voice, undermining the carefully constructed narrative of German air superiority and invulnerability. Fischer's Focke-Wulf fighters reached Berlin 15 minutes after the Mosquitoes had already departed, racing northwest at maximum speed toward the Dutch coast. The German pilots had climbed as quickly as possible, but starting from ground level against targets already at altitude and travelling at speeds matching their own maximum velocity made interception impossible without perfect advance positioning. This represented the core problem the Luftwaffe would face for the remainder of the war. The Mosquito moved fast enough that successful interception required knowing its target and route well in advance, allowing German fighters to gain altitude advantage before the bombers arrived. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Without that foreknowledge, the wooden aircraft simply outran pursuit. At 13:25 that same afternoon, 3 more Mosquitoes from 139 Jamaica Squadron departed RAF Marham, navigating through deteriorating weather toward Berlin, for a second strike timed to coincide with Reich Minister Joseph Goebbels' address at the Schöneberg Sportpalast rally at 1600 hours. Squadron leader Donald Darling commanded the formation, flying Mosquito DZ-367, with flying officer Bill Wright as his navigator. Sergeant Joe Massey piloted DZ-379 with Richard Fletcher navigating. Flight Sergeant Pete McGeehan, Royal New Zealand Air Force, flew DK-337 with flying officer Reg Morris. The second wave encountered fully alerted defences. Every anti-aircraft battery in Berlin had been ordered to maximum readiness. Luftwaffe fighters patrolled at altitude, waiting for the anticipated follow-up attack. Yet the Mosquitoes still reached their target, arriving precisely as Goebbels stepped to the lectern. The raid achieved its propaganda objective, with Goebbels forced to deliver his address punctuated by the sounds of bomb explosions, roaring Merlin engines, and anti-aircraft fire audible even through the radio broadcast. But this time the defences drew blood. As the Mosquitoes departed Berlin, flak batteries saturated the sky with 88mm shells, the explosive rounds creating clouds of shrapnel through which the aircraft had to fly. DZ-367 took a direct hit to the starboard engine, the explosion severing fuel lines and igniting aviation gasoline. Darling fought to control the aircraft as it lost altitude rapidly, but the fire spread too quickly. The Mosquito crashed north of Berlin, killing both Darling and Wright instantly. They became the first RAF casualties of what would become a sustained Mosquito campaign against the Reich capital, a campaign that would eventually see these wooden bombers attack Berlin more nights than heavy bombers, creating a psychological burden on the German population that exceeded their physical destructive capacity. The January 30th raids proved several crucial concepts simultaneously. First, that the Mosquito could reach Berlin in daylight and survive, something considered impossible for unescorted bombers. Second, that German radar and fighter defences, while formidable, couldn't guarantee interception of high-speed, high-altitude targets. Third, that precision timing could achieve psychological effects disproportionate to physical damage. The humiliation of having Goering's and Goebbels' speeches disrupted by British bombs represented a propaganda defeat that no amount of physical destruction in British cities could offset. Goering's fury was immediate and personal. Within days he ordered the formation of specialised Jagdgeschwader units dedicated exclusively to hunting Mosquitoes. Jagdgeschwader 25, under Oberstleutnant Herbert Ehlefeld, and Jagdgeschwader 50, commanded by Major Hermann Graf. These units, despite their impressive commanders and experienced pilots, achieved minimal success against the elusive wooden aircraft. The fundamental problem wasn't pilot skill or aircraft performance, but mathematics. A German fighter at ground level, even if scrambled the instant a Mosquito crossed the coast, couldn't climb fast enough to reach interception altitude before the bomber completed its mission and departed. The German technical establishment struggled to comprehend how Britain had achieved such performance from wooden construction. Luftwaffe intelligence reports from late 1942 described the Mosquito in almost disbelieving terms, noting its speed exceeded the Focke-Wulf 190 fighter at most altitudes, that it could carry a bomb load comparable to much larger aircraft, and that its wooden construction appeared to make it partially invisible to radar. Captured RAF aircrew, when interrogated about the Mosquito's specifications, provided information so extraordinary that German intelligence officers initially dismissed it as deliberate disinformation. The reality was that the Mosquito represented a convergence of technologies and design philosophies that German aerospace doctrine had rejected as primitive. Wooden construction was considered obsolete, suitable only for training aircraft and gliders. The concept of an unarmed bomber, relying entirely on speed for survival, violated every principle of defensive armament theory. The two-man crew sitting side by side rather than in separate compartments seemed inefficient compared to specialized crew positions in heavy bombers. Yet each of these supposedly inferior design choices contributed to the Mosquito's extraordinary performance. By removing defensive armament, gun turrets, armor plate, and the multiple crew positions required to operate them, de Havilland saved approximately 3,000 pounds of weight. That weight savings translated directly into higher speed and greater range. The twin-engine configuration using proven Merlin engines provided redundancy and power, while the streamlined wooden fuselage created minimal aerodynamic drag. The result was an aircraft that could fly higher and faster than fighters designed specifically for interception, while carrying bomb loads that heavy bombers labored to deliver. The German response to the Mosquito problem revealed the limitations of their tactical doctrine. Throughout 1943, Luftwaffe units attempted various interception methods, all with limited success. High-altitude patrols positioned Messerschmitt 109 fighters above probable Mosquito routes, hoping to dive on them from advantageous positions. This sometimes worked, but required perfect timing and positioning, with any miscalculation allowing the Mosquito to simply accelerate past the diving fighters. The Germans discovered that their interceptors needed at least 3,000 feet altitude advantage and perfect positioning to successfully engage a Mosquito, conditions rarely achieved in combat. Focke-Wulf One Ninety fighters, considered among the finest in the Luftwaffe, could match Mosquito speed at certain altitudes, but lacked the climb rate to reach interception positions quickly. Messerschmitt 109G. Variants with boosted engines achieved better high-altitude performance, but sacrificed maneuverability. The Heinkel He 219, designed specifically as a high-performance night fighter, represented Germany's most capable Mosquito interceptor, but only 15 were ever built due to production priorities and material shortages. Even when He 219 pilots achieved interceptions, the Mosquito's superior speed at altitude often allowed escape through aggressive evasive maneuvers. The psychological burden on Luftwaffe crews became significant enough that Germans coined the term Moskitoschreck, Mosquito terror. German fighter pilots, particularly night fighter crews, developed persistent anxiety about encountering Mosquitoes that could appear without warning, attack with devastating effectiveness, then disappear before effective response. This psychological effect extended beyond actual combat encounters. Luftwaffe pilots sometimes crash-dove to landing approaches when they mistakenly identified other aircraft as Mosquitoes, exhausting themselves and their ground crews responding to threats that didn't exist. RAF Bomber Command recognized the Mosquito's unique capabilities and began exploiting them systematically. In June 1943, the Light Night Striking Force formed within Bomber Command, composed primarily of Mosquito bombers. Their mission was twofold: serve as pathfinders marking targets for heavy bomber formations and conduct independent high-speed raids that German night fighters couldn't effectively intercept. The pathfinder role proved crucial. Mosquitoes, equipped with oboe radar navigation systems, could mark targets with precision impossible for heavy bombers, improving bombing accuracy dramatically while reducing losses among the slower aircraft. The oboe system, first used operationally by 109 Squadron on December 31, 1942, represented Britain's answer to the chronic problem of navigation and target finding at night. Two ground stations in England transmitted radio signals that intersected at precise points over German territory. Mosquito navigators, monitoring the signals on specialized equipment, could determine their exact position and release markers or bombs with remarkable accuracy, even through complete cloud cover. The system's range extended to the Ruhr industrial area initially, then to Berlin as more powerful transmitters deployed. For the Light Night Striking Force, Mosquitoes became nuisance bombers in the most effective sense. They would arrive over German cities in small numbers, sometimes just 3 or 4 aircraft, dropping 4,000-pound cookies on urban areas with timing calculated to maximize psychological impact. Raids timed 2 hours before factory shift changes disrupted sleep cycles, creating exhausted workforces. Multiple small raids throughout a single night prevented effective rest and kept air raid sirens sounding constantly. The physical damage from individual Mosquito raids was modest compared to heavy bomber formations, but the cumulative psychological effect proved devastating. Berlin became the primary target for this campaign. Between November 1943 and March 1944, during what became known as the Battle of Berlin, heavy bomber formations attacked the city 16 times, suffering catastrophic losses. Bomber Command lost more than 500 aircraft in these raids, with crews killed or captured at rates exceeding 5% per mission, above the threshold considered sustainable. Yet during this same period, Mosquitoes flew hundreds of sorties against Berlin with loss rates below 1%, demonstrating that speed and altitude provided protection that defensive armament and armor plate could not. The disparity in loss rates revealed fundamental truths about bomber operations that challenged pre-war doctrine. Heavy bombers, despite their defensive armament and ability to fly in mutually supporting formations, suffered attrition that would have destroyed Bomber Command if sustained long-term. Mosquitoes, completely unarmed in bomber variants, survived at rates that made them the most cost-effective bomber in RAF service when measuring bomb tonnage delivered per aircraft lost. The two-man crew requirement meant Mosquito losses killed or captured 2 men rather than 7, further improving the strategic calculation. German civilians in Berlin developed a particular dread of Mosquito raids because they were unpredictable and nearly impossible to stop. Heavy bomber formations could be detected assembling over England, their route and probable target predicted, allowing civil defense preparations and fighter positioning. Mosquitoes arrived without warning, individually or in small groups, at any hour of day or night, dropping their bombs and departing before fighters could scramble. Air raid sirens sounded constantly in Berlin during late 1943 and early 1944, disrupting normal life and industrial production even on nights when raids didn't materialize. The production statistics told the story of the Mosquito's strategic value. A single Mosquito required approximately 4 months to build and cost £45,000. A Lancaster heavy bomber required 9 months and £58,000. The Mosquito carried half the bomb load at 3 times the speed with 1/3 the crew requirement, achieving roughly equivalent operational effectiveness at half the cost. When factoring in loss rates, with Mosquitoes surviving more than 3 times as many missions as heavy bombers, the cost-effectiveness advantage became overwhelming. Yet the Mosquito's greatest contribution wasn't measured in tonnage dropped or targets destroyed, but in the psychological burden it placed on German air defences and civilian population. The wooden aircraft forced Germany to maintain fighter units, anti-aircraft batteries, and radar stations, defending against raids that conventional doctrine said shouldn't be possible. Resources diverted to countering the Mosquito threat couldn't defend against heavy bombers or support ground forces. The constant alert status exhausted fighter pilots and ground crews, degrading overall defensive effectiveness even when Mosquitoes weren't present. Göring's reported statement, whether apocryphal or genuine, captured German frustration perfectly. "It makes me furious when I see the Mosquito. I turn green and yellow with envy. The British, who can afford aluminum better than we can, knock together a beautiful wooden aircraft that every piano factory over there is building, and they give it a speed which they have now increased yet again." The comment revealed the psychological impact on German leadership of watching a supposedly primitive wooden bomber outperform the finest products of German aviation industry. The technical reality behind the Mosquito's success lay in engineering details that German intelligence consistently underestimated. The wooden monocoque construction method wasn't primitive but highly sophisticated, requiring precision manufacturing and quality control exceeding metal aircraft assembly. The balsa-birch-balsa sandwich construction distributed stresses evenly across the airframe, creating strength-to-weight ratios that aluminum struggled to match. The casein glue bonding the layers required careful temperature and humidity control during curing, with factories maintaining precise environmental conditions to ensure bond integrity. Construction involved skilled craftsmen rather than assembly line workers. Furniture manufacturers and boat builders brought expertise in working with wood that aircraft factories lacked. Piano factories, with their experience creating complex wooden structures with precise tolerances, proved particularly valuable. This distributed manufacturing approach meant Mosquito production could expand rapidly without competing for the skilled metal workers required for Spitfire and Lancaster production, essentially creating bomber capacity from resources that otherwise wouldn't contribute to aircraft manufacture. The Rolls-Royce Merlin engines that powered the Mosquito represented the finest liquid-cooled piston engines in production. The same engine family powered Spitfires, Hurricanes and Lancasters, creating logistics advantages and production economies of scale. For the Mosquito, Merlin 21 and Merlin 25 variants generated 1,500 horsepower each, driving the aircraft to maximum speeds exceeding 400 miles per hour at altitude. Later, variants with upgraded Merlin engines achieved even higher performance, with some photo reconnaissance versions reaching 430 miles per hour. The crew of two, pilot and navigator, sat side by side under a clear perspex canopy that provided excellent visibility. This arrangement, unusual for British bombers, allowed constant communication without intercom systems and gave both crew members similar situational awareness. The pilot handled flight controls and engine management. The navigator operated navigation equipment, oboe systems when installed, and handled bomb release. In fighter and night fighter variants, the navigator operated radar equipment and directed the pilot toward targets. This efficient division of labor meant 2 men could perform missions requiring 7 crew members in heavy bombers. The operational flexibility of the Mosquito design allowed rapid adaptation to emerging needs. Photo reconnaissance variants, stripped of weapons and carrying cameras in the bomb bay, could photograph targets deep in German territory with near immunity to interception. Fighter variants, armed with 420mm Hispano cannons and 4.303-inch Browning machine guns, proved devastatingly effective against German bombers and night fighters. Fighter-bomber variants combined both roles, carrying bombs while retaining offensive armament for self-defense and opportunity targets. The most specialized variant, the thirtieth, mounted a single 57mm Molins anti-tank gun in the nose, specifically designed to attack German U-boats. This massive weapon could fire 75 rounds in 60 seconds, with armor-piercing shells capable of penetrating submarine pressure hulls, even when the boat was submerged. The installation required extensive structural reinforcement and resulted in significant recoil forces, but proved remarkably effective in the few combat deployments it saw. German submarine crews learned to fear the distinctive profile of tsetse-equipped Mosquitoes, knowing their wooden construction made them difficult to detect on radar, until too late for effective crash diving. The climax of the Mosquito's strategic impact occurred during the final year of the war, when German air defences had deteriorated to the point where effective response became impossible. From September 1944 through May 1945, Mosquitoes attacked German cities nightly with near impunity. The Light Night Striking Force operated from bases in England and liberated France, reaching targets across Germany that heavy bombers couldn't attack without prohibitive losses. Berlin endured 36 consecutive nights of Mosquito raids in March and April 1945, ending only when Soviet ground forces reached the city outskirts. The psychological effect on German civilians exceeded anything heavy bomber raids achieved. Lancaster formations dropping thousands of tons of bombs created spectacular destruction, but happened relatively infrequently, allowing recovery between raids. Mosquito attacks, carrying modest bomb loads but arriving unpredictably every night, prevented normal sleep patterns and created constant anxiety. Factory workers arrived at shifts exhausted from interrupted sleep. Civil defense personnel remained on alert, continuously. The cumulative effect degraded industrial production and civilian morale more effectively than occasional devastating raids. German fighter pilots, particularly those assigned to night fighter units, experienced similar psychological degradation. The omnipresence of Mosquito intruders over German airfields meant that landing after combat missions carried significant risk. British Mosquito night fighters, equipped with serrate radar detectors that could track German night fighter radar emissions, would lurk near Luftwaffe bases waiting for returning aircraft. German pilots, already stressed from combat operations, faced the additional burden of knowing that the moment they entered landing pattern represented peak vulnerability. Many German night fighters crashed during hasty landing approaches, pilots prioritizing speed over safety to minimize exposure to Mosquito attack. The statistical record of Mosquito night fighter operations demonstrated effectiveness disproportionate to numbers deployed. 100 Group, formed within Bomber Command, specifically to provide fighter support for heavy bomber operations, operated Mosquitoes, equipped with specialized radar and radio equipment. From November 1943 through war's end, these aircraft claimed approximately 258 Luftwaffe night fighters destroyed, for losses of roughly 70 Mosquitoes. The exchange ratio heavily favored the British, but the psychological impact on German crews far exceeded the numerical losses, creating hesitation and caution that degraded overall defensive effectiveness. Oberleutnant Kurt Welter, commander of 10 Staffel Night Fighter Group 11, represented the rare German pilot who achieved consistent success against Mosquitoes. Flying specialized Messerschmitt Tu-62 jet fighters adapted for night operations, Welter claimed approximately 25 Mosquito kills, demonstrating that with proper equipment and positioning, interception remained possible. However, Welter's success was exceptional, requiring jet fighters that Germany couldn't produce in sufficient quantities due to material shortages and Allied bombing of manufacturing facilities. The handful of successful anti-Mosquito pilots proved the exception that highlighted the general futility of conventional defensive measures. The introduction of German jet fighters in late 1944 represented the only technology that could reliably intercept Mosquitoes. The Messerschmitt Tu-62, with maximum speed exceeding 500 miles per hour, possessed performance margins sufficient to catch even the fastest Mosquito variants. However, chronic fuel shortages, manufacturing difficulties, and pilot training limitations meant that Me-262 units rarely achieved operational readiness. Most of the approximately 1,400 Me-262s produced spent the war grounded for lack of aviation fuel, while Allied bombing disrupted pilot training programs that would have made them effective combat aircraft. The few documented successful intercepts of Mosquitoes by jet fighters validated German concerns while simultaneously demonstrating the lateness of their technical response. On July 25, 1944, Lieutenant Alfred Schreiber, flying an Me-262A1A, intercepted a photo reconnaissance Mosquito PR Mark 16 in the Munich area. Schreiber made 6 attack passes, but the Mosquito crew, Flight Lieutenant Wall and Flying Officer Lobban, successfully evaded through violent maneuvering and cloud cover, making an emergency landing in Italy. The engagement proved that jets could reach Mosquitoes, but that destruction wasn't guaranteed, even with performance advantage. The British response to the jet threat came in the form of the Mosquito PR Mark 32, a specialized photo reconnaissance variant with extended wingspan and high-altitude superchargers that raised its operational ceiling to 42,000 feet, above the service ceiling of the Me-262. This variant entered service too late and in too few numbers to significantly affect operations, but demonstrated Britain's ability to respond to emerging threats through rapid aircraft modification, an advantage Germany could no longer match, given degrading industrial capacity. The final year of the war saw Mosquitoes operating across multiple theatres with consistent success. In the Mediterranean, they attacked Italian and German positions, supporting Allied ground forces in Italy. In the Pacific, late war variants, adapted for tropical operations, began deploying against Japanese targets, though the war ended before they saw extensive combat. In northwest Europe following D-Day, Mosquitoes from 2nd Tactical Air Force provided close air support and struck German communications and supply lines with precision impossible for heavy bombers. The Operation Jericho raid on Amiens prison, executed on February 18, 1944, exemplified the Mosquito's unique capabilities. 19 Mosquito fighter bombers from 464 Squadron Royal Australian Air Force, 487 Squadron Royal New Zealand Air Force, and 21 Squadron RAF attacked the prison at low level with extreme precision. Their mission was to breach the walls, allowing imprisoned French resistance members to escape before scheduled executions. The attack succeeded, with bombs precisely striking the prison walls and guards' quarters. 258 prisoners escaped, though many were recaptured. Several Mosquitoes were lost to anti-aircraft fire, but the mission demonstrated capabilities no other aircraft possessed: the speed to reach distant targets at low altitude, the precision to hit specific building sections, and the survivability to return despite intense defences. The raid on Gestapo headquarters in Copenhagen on March 21, 1945, showed both the Mosquito's precision capabilities and the risks of low-level operations in urban areas. The attacking force successfully destroyed the target building, but the strike leader's Mosquito clipped a bridge and crashed into an elementary school, killing many children. The tragedy highlighted that precision attacks in cities carried inherent risks that even the most skilled crews couldn't entirely eliminate. But the alternative of high-altitude bombing would have caused far greater collateral casualties, while being less likely to destroy the specific target. As the war entered its final months, Mosquito operations shifted toward supporting advancing Allied ground forces and interdicting retreating German formations. The aircraft's combination of speed, firepower, and precision made it ideal for attacking tactical targets: bridges, railroad yards, vehicle convoys, and troop concentrations. The Mosquito could reach targets quickly, identify specific aim points, deliver weapons accurately, and depart before effective response, capabilities that heavy bombers couldn't match. This tactical flexibility, combined with strategic bombing and reconnaissance roles, made the Mosquito arguably the most versatile combat aircraft of the war. The production statistics revealed the industrial achievement the Mosquito represented. Between 1940 and 1950, approximately 7,780 Mosquitoes were built across 3 continents: Britain, Canada, and Australia. De Havilland's original factory at Hatfield produced the prototypes and early variants. Airspeed, Standard Motors, and Percival Aircraft in Britain manufactured subsequent marks. De Havilland Canada built over 1,000 aircraft adapted for Canadian production methods. De Havilland Australia produced small numbers primarily for Pacific operations. This distributed production demonstrated that wooden construction enabled rapid capacity expansion using workforce and facilities that couldn't contribute to metal aircraft manufacture. The loss rates told the final story of the Mosquito's success. RAF Bomber Command compiled statistics showing that Mosquito bomber variants ended the war with a loss rate of 0.63%, the lowest of any aircraft in Bomber Command service. Lancasters suffered 2.13% losses. Stirlings lost 3.81%. Blenheims, the aircraft Mosquitoes replaced in many squadrons, suffered 3.62% losses. When measuring effectiveness in terms of bomb tonnage delivered per aircraft lost, Mosquitoes achieved twice the performance of heavy bombers while requiring only 2 crew members rather than 7, making them 3 to 4 times more cost-effective in terms of lives risked per ton of explosives delivered. Air Marshal Andrew Cunningham, First Sea Lord of the Royal Navy, evaluating the war's naval and air campaigns, identified the Mosquito as among the most strategically significant aircraft deployed, not for tonnage dropped or enemies destroyed, but for the disproportionate burden it placed on German defences. Every Luftwaffe unit assigned to counter Mosquitoes, every anti-aircraft battery positioned to defend against high-speed raiders, every radar station dedicated to detecting wooden aircraft represented resources diverted from defending against heavy bombers or supporting ground forces. The psychological burden on German fighter pilots, civilians, and leadership exceeded the physical damage inflicted, creating effects that conventional bombing struggled to achieve. The German post-war analysis, conducted by former Luftwaffe officers for Allied intelligence services, concluded that the Mosquito represented what they termed a capability-breaking system. Unlike conventional weapons that merely improved on existing capabilities, the Mosquito invalidated entire operational concepts. German doctrine held that bombers required heavy defensive armament and armour to survive. The Mosquito proved speed alone provided superior protection. German theory stated that wooden construction was obsolete and inferior to metal. The Mosquito demonstrated that properly designed wooden aircraft could outperform metal competitors. German intelligence believed that radar made stealth irrelevant. The Mosquito's accidental reduced radar signature showed that material selection and design could defeat detection systems. The technical lessons from the Mosquito influenced post-war aircraft design significantly. The emphasis on speed over defensive armament became doctrine for bomber design, culminating in aircraft like the English Electric Canberra and later the B-58 Hustler, which relied entirely on speed for survival. The recognition that multi-role capability provided operational flexibility influenced designs like the F-111 and later multi-role fighters. The Mosquito demonstrated that specialist high-performance aircraft, even when produced in relatively small numbers, could achieve strategic effects through capabilities that mass-produced conventional aircraft couldn't match. Perhaps the most significant lesson was psychological rather than technical. The Mosquito proved that innovative design could overcome material and industrial disadvantages. Britain, facing aluminium shortages and industrial capacity constraints, created a world-beating aircraft from wood, glue, and furniture factory workers. Germany, with superior industrial capacity and material availability in the war's early years, failed to develop an equivalent aircraft because doctrine and engineering culture discouraged unconventional approaches. The Mosquito succeeded precisely because it violated conventional wisdom, demonstrating that innovation requires willingness to challenge established doctrine. The Wooden Wonder, as RAF crews affectionately called it, represented the confluence of necessity and innovation. Material shortages forced consideration of wooden construction. Pre-war racing aircraft experience proved its viability. Strategic requirements for high speed, long-range reconnaissance and bombing drove performance specifications. Skilled craftsmen in furniture and boat-building industries provided manufacturing capability. Each element was necessary but insufficient alone. Their combination created an aircraft that exceeded the sum of its parts. For German defenders, the Mosquito represented a persistent reminder of technological and tactical defeat. They had anticipated fighting lumbering heavy bombers that defensive doctrine could counter. Instead, they faced wooden aircraft that radar struggled to detect, that flew faster than fighters, that struck unpredictably day and night, and that survived at rates making attrition warfare impossible. The psychological burden, the constant fear of the Mosquito Schreck, degraded defensive effectiveness even when Mosquitoes weren't present, creating hesitation and caution that reduced overall combat performance. The final Mosquito operational sortie in Europe occurred on May 21, 1945, when aircraft from 143 and 248 Squadrons RAF patrolled Norwegian and Danish waters, searching for German submarines that might attempt to continue fighting despite the general surrender. They found none. The U-boat force, having endured years of technological disadvantage and mounting losses, had accepted defeat. The wooden aircraft that had contributed to that defeat through direct anti-submarine operations and by forcing resource diversion to air defense had proven that innovation could triumph over conventional superiority. In Berlin, where the Mosquito campaign had begun with those audacious daylight raids in January 1943, the final raid occurred on the night of April 20th, 21st, 1945, hours before Soviet forces reached the city centre. Mosquitoes dropped their last bombs on the Reich capital, ending a campaign that had subjected Berlin to more attacks than any other German city. The wooden aircraft that German engineers had dismissed as primitive, that Luftwaffe intelligence couldn't believe could perform as reported, had proven its worth through 3 years of sustained operations that conventional doctrine said were impossible. The crews who flew the Mosquito spoke of it with affection and respect. The aircraft's handling characteristics, its speed and responsiveness, the confidence it inspired through sheer performance, created a bond between pilot and machine rare in aviation history. They trusted the wooden construction that seemed so fragile to those who didn't understand it. They relied on the Merlin engines that pushed them beyond enemy reach. They appreciated the side-by-side seating that made crew coordination natural and immediate. Most importantly, they survived at rates that made Mosquito duty among the safest in bomber command, a force where survival often seemed more dependent on luck than skill. The story of the Mosquito remains relevant decades after the war ended. It demonstrates that technological advantage doesn't necessarily come from the newest materials or most advanced manufacturing methods, but from innovative application of available resources. It shows that operational doctrine should adapt to technical capabilities rather than constraining them. It proves that sometimes the most effective solution violates conventional wisdom, requiring courage to develop and deploy despite skepticism. The wooden aircraft that couldn't be built, that wouldn't perform as designed, that couldn't survive against German defences, became the most effective bomber in RAF service by measures of cost, survival rate, and strategic impact. The de Havilland Mosquito proved that innovation requires challenging assumptions, that necessity drives creativity, and that sometimes the best answer comes from unexpected directions, the lessons written in the contrails over. Berlin, sketched in pencil marks on navigation charts, calculated in loss rates that defied prediction, remain relevant whenever conventional solutions prove inadequate, and circumstances demand unconventional thinking. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.